Welcome back. This is an Aleks training video on identifying a molecule from its electrostatic potential map. An electrostatic potential map is where a computer generates colors based on whether something is positive on that side of a molecule or negative. And really all it's talking about is that you have a bond where you have two elements that are sharing an electron unequally. So one of the elements is pulling the electron pair to itself more than the other is. And if you pull an electron pair to one side, that side becomes more negative and the other side becomes more positive. So it's a tug of war between the electrons. Whoever is winning that war becomes more negative on that side, and the other player becomes more positive. Okay, so they're going to give you a shape. They're going to tell you, obviously, by this that there's going to be three elements. Okay, so I've got three elements here. I know that it's not linear. I know that it's bent. I know that the central atom is going to be more positive than the end atoms. So from there, you can basically just start knocking out a bunch of possibilities that it can't be, and then just pick the ones that is still possible. Okay. On the right, I've given you the Lewis diagrams of all of these different options. So I think I did 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. Yeah. SO2 is the hard one. It's a resonance structure between two different forms of one of the bonds is a double bond, the other one is a single bond. Okay, so but it flips back and forth instantly, and so it's almost like you've got a half double bond on both sides. Okay, kind of, because it's going back and forth instantly. So if I look at here and there's more than three elements, then I don't have any of my choices on this problem, but you may have it on a different problem. If there's more than three elements and I see three elements in my picture, I can't have that one. I kick it out. This one shows me that it's bent, and so when I do the Lewis dots, I can see which ones are bent. Okay, when if I'm up here with the carbon and hydrogen bond, well, that's just going to be a straight line bond. And then a triple bond here is always going to be straight line, so this is going to be linear. This is going to be a straight line, so it can't be this one. All right, this is a double bond, and this is a double bond, so this is a linear one. There's no bend there. Water is bent. Okay, so water is a possibility. The sulfur difluoride is a possibility, and the sulfur dioxide is a possibility. So you only have three possibilities. Is there any of these three that it cannot be? Okay, so let's look at the positives and negatives. Whichever is going to be more electronegative is going to take the electron more and become red. Okay, so whichever one becomes more electronegative. Well, let's look at water. Water is bent. Okay, I've got water here. I've got H2O, it's bent. So if I look at water, this is positive, and this, in this case, is oxygen, and oxygen is over here. Very, very high electronegativity. Okay, the hydrogen over here has a low electronegativity, so it's not going to steal the electron. This is backwards. If you were drawing a water molecule, the hydrogens would be blue, and the oxygen would be red. So if blue is positive, so this one cannot be. So water cannot be. Right. So I've already seen that that cannot be one. This cannot be one. And this cannot be one. What about the other ones? Or is it possible to have the other ones? Yeah, there's nothing else to see it, because sulfur is going to be blue, and the fluorines are going to be red. Well, that means the fluorines should have a higher electronegativity than the sulfur. Well, is that true? The fluorine is up here. That's a 4. That's the highest that there is. And then the sulfur is down here at a 2.5. Yeah, this is possible. Okay, so this is a possibility. So I'm gonna say that SF2 could be one of them. All right, that's possible. What about the SO2? The SO2, does oxygen have a higher electronegativity than sulfur? Well, oxygen is 3.5. Oxygen is 3.5 right here. Sulfur is 2.5. So yes, that's possible. Okay, so which means that that the SO2 is also a possibility. So you have two possibilities. So I hope you're helped. See you in class.